Hi everybody, this is section 6.4. It'll be the last of our factoring techniques for the time being. And then we're going to use our factoring techniques after this. This one's going to go really quick. This will be a very simple and easy factoring strategy. These are called difference of squares. You can always recognize them because they all have two terms. Okay, they can only have two terms. Like the GCFs can have as many terms as possible. It could be up, from 2 to whatever. The trinomials have to be 3 terms, and they have to be in that ax squared plus bx plus c form. And these have to have 2 terms. Oops. So they have to have 2 terms. What's wrong with this pen? 2 terms. They both have to be perfect squares, which we'll talk about. Okay, and it has to have a subtraction sign between them. Okay, difference meaning subtraction of squares, perfect squares. All right, so let's get a list of what our perfect squares are. For numbers, we have 1, 4, 9, 16, 25. What am I doing? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6, 7, 8, 9, 10, ... Okay, so if I would take the square root of any of these, I get a nice even number. Square root of 25 is 5. Anything else that's between these numbers gives me some sort of messy decimal. It's not a perfect square. So yes, they do have a square root, but they're not perfect, and perfect in this case means they come out whole numbered. All right? And then any even-powered variable. X squared, x to the 4th, x to the 6th, x to the 8th, ... Because whenever we take the square root of any of these, we just take them in half. All right? Okay, so the first thing that you want to do is you want to recognize that these are difference of squares. And this one is, I have a perfect square, right? Because I've got an even-powered variable and an even-powered variable. All right, so that's right here. I've got 2 terms, and I've got a subtraction between them. That qualifies. So anytime that I have a perfect square minus a perfect square, these factor into 1 plus, 1 minus. All right, it's always plus minus or minus plus, doesn't matter on the order. And I take the square root of the front one and I put it in the front. So the square root of a squared is a. So I put that here. And the square root of the back one goes in the back. So the square root of b squared is b. So this is your formula right here. Anytime I have a perfect square minus a perfect square, it factors into the square root, and it's always 1 plus 1 minus. Okay? So this is, this one's obviously that one. A plus b, b plus a minus b, a plus b. Oh, why does that look so weird? Isn't that weird? This is different. This is like a different box. Nice. All right. Not sure why that changed. So, let's try this one. X squared minus 81. Does it qualify? My x squared has an even power and my 81. Let's see, is it on my list? Yep, 81 is perfect. And x squared is perfect. And I have a subtraction between them. So I'm good to go here. 1 plus, 1 minus. See how easy these are? Take the square root of this one. Take the square root of that one. And I just plunk them in the front and the back. So let's check that one. Refoil. First term, x squared. Outside, minus 9x. Inside, plus 9x. Last, negative 81. Now these are always going to be the same numbers, but opposite signs, so they always cancel each other out. So we're left with x squared minus 81. Check. Okay? So when you put these in here, you're going to want to, and it doesn't matter on the order, you can do the negative first or the positive first. Well, you have to have an x. Okay. Oh, now we're back to this kind of a box. The first one was kind of weird. All right, and these are all done the same. 144. Is 144 perfect? Well, it's not on my list because I didn't go up that high, but you can always check it this way, right? Isn't the square root of 144 12? Okay, so if it comes out nice and neat like this, then you're good to go. So this would be x plus 12, x minus 12. All right, so now don't do these any differently. All right, check. Is every piece of this perfect? Is 49 on my list? Let's just go up here. Yes. Is x squared on my list? Yes. Is 1 on my list? Yes. So they're all perfect, and all pieces have to be perfect. This time I've got 3 little pieces here rather than just the 2 to check. Okay? So again, we're going to have 1 plus 1 minus. Square root of 49 is 7. Square root of x squared is x. And the square root of 1 is 1. So in the front, since I've got 2 things in the front, I'm going to put both of these in the front for 7x, 7x, and I put my 1's in the back. And I can refoil the check. Same thing here. We've got 16, x squared, 81, all perfect. Subtraction between them. Now don't turn this one around. I see this a lot. Is this perfect? Yes. Is this perfect? Yes. Is there subtraction between them? Yes. 1 plus 1 minus. Square root of 64 is 8. The square root of x squared is x. A lot of people want to put the x in the front. That's not what this is telling me to do. There's no rule that says that the x has to come first. My rule on this is whatever the square root of the front term goes in the front, and whatever the square root of the back one goes in the back. So don't flip-flop these. I see that a lot. I see this a lot. And although these are the same, these are not. Right? Here I have a positive 8 and a negative x. Here I have a positive x and a negative 8. So this is not correct. So just whatever's in the front goes in the front. This is the same. Now you've got 4 pieces. Maybe we should do that one real quick. So we have 36x squared minus 169y squared. So I'm going to take each piece. I've got 4 of them now. 1 plus 1 minus. I'll take the square root of all of these. Okay? And they all have to be perfect, so they all have to come out nice and neat. This is 6. This is x. This is 13. I should check that. Pretty sure it is. 169. Yep. And this is y. So my front 2, which are these 2, go in the front. 6x, 6x. And the back 2 go in the back. 13y, 13y. Done. Right? And that is almost exactly the same as this one, except that this will be a 12, right? It'll be a 12x plus 13y, 12x minus 13y. So that's it. Under 10 minutes. Bing, bada, boom. These are easy. The next section is going to be a little tougher just because they're going to be all mixed up. And the hard part about factoring sometimes is understanding or recognizing what type of factoring problem you have. Okay, so when we go through these in sections, this entire section is difference of squares, so they're all difference of squares. But if I mix those up with the GCFs and the trinomials and all that kind of stuff, and maybe some that have 2 and 3 pieces to them, then it becomes a little bit more difficult. So that's what we're going to work on. And we're going to actually start setting these equal to something. So, you know, here if we would have, you know, a difference of squares, obviously that's x plus 3, x minus 3. But if I would set that equal to 0, then now I'm looking for, okay, what number goes in there? And so that's what we're going to head to next, is we're going to actually start setting these equal to something and solving. All right, so practice up your difference of squares, and then we will use all this factoring in the next section. So I'll see you then.